So today we have to start MPLS. To understand MPLS VPN, I don't know whether you have done in CCNP or MPLS or not, but here I am going to take up because if you have not done, then there's no point of learning MPLS VPN, right? So VRF, we have done VRF Lite initially, like when we started this class. And that is required, device that MPLS is required. Okay, so I'll give you first of all an architecture of your MPLS only, not VPN, how it works actually. What is MPLS? So today we're going to see that basic. So MPLS reference architecture. Now it's a fastest switching method. Okay, how that we're going to see. Okay, where we said that like normally in a routing table environment we have ceph, fast switching and all those things. We'll discuss on that also. But MPLS is the fastest switching method. Here we're going to decide not on the basis of destination IP, we're going to decide on the basis of labels. That we need to understand. Okay, so first of all we'll see the architecture and then we'll move further. So we have customer edge, provider edge, customer edge, provider edge. Here we have P router, P router, P router, P router. And then we have provider edge, and we have provider edge here. And then again, customer is connected to some other location. It could be different city, different country, it could be anything. Now, this is your provider router, service provider, and P core routers are like interconnected for redundancy concept. Okay. Now, try to understand. Customer is connected to provider edge. Now, this provider edge, when you'll do MPLS VPN, this will become the main router. Here, all the troubleshooting will happen. But still, we need to understand about this MPLS architect, so we won't discuss anything on MPLS VPN. From here to here, it is called label switch path because here the decision will be done on the basis of label switch. So it is called label switch path. Okay. Accordingly, this is the fastest method called label switching. Fastest method label switching. Okay. So to do MPLS, always remember ceph should be enabled. You make sure on your Cisco routers ceph should be enabled for MPLS. Otherwise, MPLS won't work. I will tell you a reason also. Okay. Now, Actually, what happened is, I'll just give you an overview. Three things are very important here. Push concept is there, swap concept is there, and pop. So right now we'll discuss on that basic concept today. Then we'll go in the core on Monday on. Okay. So from the customer, when you initiate anything, it is like a normal route, like you have L1, L2, L3. You need to understand MPLS is like between L2 and L3. It's called L2.5. Between layer 2 and layer 3, we have something called Mpls header. It's called L2.5 Mpls. Complete structure I will tell you step by step. We will discuss. This concept will take time. Okay. Here we have to put. I will teach you about the header also of Mpls. Now, when packet will going to hit here, this is normal packet is going. Okay. So what will happen now? Because this is called your ingress P router. Okay, according to the flow which I am going right now, my flow packet flow is this, and accordingly this will become your egress P router. According to the flow, the same router could be ingress egress, depend on the flow. Ingress P router, egress P router, ingress P router. When you are hitting on the ingress P router, some lookup will happen. We'll discuss on that separately. Because of that lookup, they perform something called push. The push will be like this: L1, L2, and now it will insert. See, L3 will be here, and it will going to insert one label called L2.5. Suppose label number 70. Now, what happen is when packet will hit here, when it will encounter label, on the basis of this label, he will going to forward the packet. See, when you are inserting a new label, because like normal packet is coming, and you have to insert a label that is called push. When you are making decision on the base of a label, that is called, these router will do swap. Maybe this is L1, L2, L3. In L2.5, now they are saying use label number 19 to go towards next hop. Again, this P router will do something called, because you encounter label swap. Maybe it will write here L1, L2, L3, and L2.5, maybe label number 22. Okay, and when it will reach to egress P router, little bit I am telling you here wrong because they introduce some new concept, but we'll start from the scratch. So on the egress P router, what it will do, it will going to pop the label. What happen is, once it will be popped, it will be L1, L2, and L3, because it will then will go to the customer. Now try to understand, in ingress P router, you will going to insert a label called push. After that, see right now here, how I have inserted here something called CEF is involved, because it will do L3 lookup, and in the CEF table you have a label information that I will explain to you. Okay, but today just understand the basic, and then packet will move further to the P router, because now you are making, see here you made a decision on the basis of destination IP, and that too CEF lookup is helping. If CEF is disabled, it will never work. Now, because here after L1, L2, you will get L2.5, not L3. So you are encountering label. So on the basis of label, when you will going to decide, that is called swap. Again, you encounter another label, you will do swap. But on the P egress router, it will be right pop. How we're going to discuss all those. Once it will be popped, packet will going to the 2.5 Mpls header will be removed. So L1, L2, L3, and it will reach to the customer edge. Clear? On the basis of this, I'll give you few points today. Okay. So I'll just make a note. Just remember these important points, what I made. We can elaborate in another class. Now, first of all, we'll understand the terminology, this architect. Each and every component what I have put with their functionality, I'll just make a note for your reference. Now we have seen P router, which is called provider router. What is the functionality of provider router? It's a label switching router. It switch MPLS label packet. Okay. Then we have PE, provider edge. Now this is called label edge router. Different names in different books they have given. LER. Okay, it will either impress, meaning it will push the label, or pop the label and remove MPLS label. Then you have something called customer edge router. A customer edge router connect customer network to Mpls network. Okay. Then we have seen the terminology called label imposition, which is called push. So it is done by ingress P router. Router and classify and label the packet. I'll let you know the meaning later. One is called label swapping, or we call it as switching. Swap. This is done by P routers, if you will notice. Okay, and forward packet using label. Label. Okay, and then you have label disposition, which is called pop. So it is done by, according to my topology, egress, PE router, and remove the label and forward original packet to the destination CE. It removes label and forward original packet to destination CE. Egress LSR. Okay. So these are some terminologies initially you should understand so that basic will be okay. Now overall we will see what is the meaning of like MPLS, multi-protocol label switching. Now multi means multi-protocol, right? So it can carry multi-protocol, meaning the ability to carry any payload. Okay, protocol as like here multi protocol, meaning at see, like it is carrying layer 3. Now before, like in the old days, we have like IPv4, IPv6. These are like Ethernet technologies. IPv, we have ATM, frame relay, could be IPX, Apple Talk, DC Net, etc. Now only right now IPv4, IPv6 we are using. These are the old one. Now multi-protocol label. Label means it use label to tell a node what to do with the packet. Tell a node what to do with the packet. Okay, and switching means see, in this we have routing also for IPv4 and IPv6. lookup is there. Everything else is switching after that, label switching. Give me a second. sorry. Okay, so this first of all you have to remember. Okay, what is MPLS? What is push, pop, and swap? One thing is I will going to add in the next class. This is again I will repeat. We have a provider edge. We have a P router. This is first of all important thing to understand. Then step by step we're going to learn about the headers and all. Provider edge and customer edge. 1 second. Okay. So customer is not aware what you are doing. Okay. Again, GRE, IPsec, OTV, like those kind of a concept, those are called customer services. Okay. These are called, right now whatever I am teaching you, you can run in your LAN also. But when I teach Mpls VPN, that is purely service provider service. Okay. So when the packet will reach, it will come, it will do a ceph lookup. That ceph lookup will tell him to do push. So that's why I said ceph is required. Now when it will hit here, it will check. First thing it will going to encounter is your MPLS header. So that's why it do swap. When it will hit here, first thing again it will encounter MPLS and it will going to say swap it. When you will reach to the last router, okay, again MPLS lookup will be there. Here I will do some modification next time. Here it will do pop it. And then packet will do a normal. Again, once pop it, again ceph lookup will be there. And then packet will move further. So you will notice two lookups are there. So there we have a concept called penultimate hop popping. Okay. So that concept once we study, so you'll understand that actually what it will do. Okay. And the other part what we have to discuss about this is we have a lot of tables. We have a tables like what is LIB table, what is LFIB table, okay, about MPLS header, about like whether fragmentation is allowed, or because when you put an MPLS header, it increases the fragment size. Okay, meaning not fragment size, will increase the MTU size. So whether the fragmentation is required or not. Okay, what kind of different type of labels to assign. Okay, labels are locally significant. How to assign label, what to apply on the customer edge so that customer should not participate in MPLS. So like if suppose you do not want that netting private IPs should be proud. We say that private IPs are not routable over internet. So we either put ACL or URPF. Here also we'll put something. We have a concept of LDP and TDP. Okay, and then how we're going to build the table. So a lot of things are there. Okay, in the next class we're going to cover the other basic, and again we'll come back to architect, what I have explained today. So I'll rewrite penultimate hop popping, and then we'll do one basic practical on MPLS, and some tweaks are there I'll show you, and then we can move towards MPLS VPN, where RDRT concept will come. A lot of different topologies are there. There you can understand properly. Monday I'll tell you one book. One is I'll give you the name. I didn't remember, but that is Cisco Press book. Okay, go with that particular book for MPLS. But MPLS, like those books are like the books what they have made is like little complicated. Some books they focus more on practical, few theoretical, but I don't know what level of theory they are explaining more complicated way. But I'll give you, one day I'll give you the proper name of that Cisco book so that you will refer that. Okay. BGP lot of books are there because it's a part of CCNP also and I also. So in both the books they have merged. So I'll give you the proper name on Monday. Okay, Cisco doc books. Okay, so you can refer those. For now, just concentrate on in this Saturday, Sunday, revise your BGP practical, and will do properly MPLS, because see, here MP BGP will again come. So start revising your community. If I was focusing on the community also there in BGP, so revise that. So here again it will come. So you should, there in BGP we have learned standard community. Here we're going to learn extended community. So MPLS and next is multicasting. Those again, every like all concept whatever we learn, QS, IPsec, GRE, VRF, DMVPN, and your BGP, and your this Mpls VPN, multicasting, MSDP, whatever you're going to learn, they all are very core topics and very important topics. So go step by step. Okay, so today I'll stop here, and Monday we'll come into the core part of this, and then next we'll go with the step by step approach, and then we'll follow up with the practical, and then we'll move to Mpls VPN. Okay, so let's stop.